Welcome back to Weather Part 2. In this, we are going to touch upon air masses, fronts, and then low pressure systems or storms. So an air mass is a large body of air that forms and takes on the characteristics of the region it forms. If it forms over water, we call it maritime, and it means it's moist. If it forms over land, we call it continental, and it means it's dry. If it forms near the tropics, we call it tropical, and it's warm. If it forms near the poles, we call it polar. And then there is a especially frigid we characterize as Arctic air. So air masses move due to global winds. Where they come together, much like a fault is where plate comes together, where air masses come together, we call that a front. And the air masses generally meet in the mid-latitudes where we live, the middle latitudes, and that produces our weather. So we get a series of warm fronts and cold fronts caused by the meeting of air masses. Air masses, again, are classified by where they form, and I mentioned continental, maritime, polar, and tropical. This map shows you the location of where each type of air mass is formed and the symbol associated with each type of air mass. So the cold air mass generally forms in northern Canada. You can see that is moved by our westerlies. So the cold part of our mid-latitude front forms there. You can see in this image where the air masses meet and their general movement. The maritime polar is the air mass that forms over the North Atlantic or North Pacific, depending on which side of the country you are, but we're looking at the North Atlantic. That is the cause for nor'easters in the winter as the jet stream drips down and those air masses encroach and move down the east coast of the United States. The maritime tropical, the second air mass that brings us our weather. The continental polar is generally the first. We don't get nor'easters, so we get our cool air from the continental polar. We get our warm air from the maritime tropical. That's the warm, moist air. You can see how it moves off the Gulf. So much of the United States gets Gulf water when it's precipitation. And that's why when the jet stream is a little bit higher during the spring, summer, and early fall, where we live, we are consistently hot, humid afternoon thunderstorms. Hot, humid afternoon thunderstorms. That's a broken record, but that's why we are always getting water-laden air from the Gulf. So the two weather makers east of the Rockies are the continental polar and maritime tropical. Those are our two weather makers. Fronts, like I mentioned, are where the air masses meet, much like faults are where continental plates meet, and their activities are similar. You know, the warm front gets pushed up, so you have analogous to subduction. The cold air mass, which cool air sinks, subducts or goes underneath, pushing the warm air mass up, and when that warm, moist air gets pushed up, you get precipitation. So fronts are weather changers that generally bring precipitation due to rising warm air. So the warm front is when the warm air is pushing on the cooler air and it's rising up above it. So you generally have warmer temperatures associated with an incoming warm front, but you have slow, steady precipitation and then humid weather following. The profile of the warm front, you can see that warm air is being pushed up at an angle So high clouds indicate coming of a warm front, your cirrus clouds. The clouds get lower and lower and lower until finally you have stratus clouds covering much of the sky with a long period of precipitation followed by warmer and more humid conditions. Cold fronts, and you can see their symbol there, move faster because the cold air is bulldozing through the warmer air, and then generally they bring you higher pressure after they move through. Cooler, clearer air is associated with that higher pressure. So the cold air, the warm air, as it moves through. You can see the cold front moving through, pushing the air up. You start off with cumulus clouds that quickly rise up in the atmosphere, and then you have your rain associated with it, fast moving through, and then you have area of cooler, higher pressure behind it. These fronts move in association with each other and are caused by low pressure. So you have low pressure spinning counterclockwise, you get hit with a warm front, and then you have a period of warm, moist air. Then you get hit with a cold front, and you have a period of cooler, higher pressure behind it. This is called a mid-latitude cyclone, and this is what brings weather across North America. At least 2/3 of our country get this weather pattern, a mid-latitude low. It's where the maritime, tropical, and continental polar mass meet. Low pressure is formed, and it has counterclockwise or cyclonic flow. You get a warm front first, and then a period of humidity. Then you get a cold front, and then a colder, drier period. This is typical of North American weather. When the cold front, which moves faster, catches up to the warm front, you have what is called an occluded front. And then if a front were to stall out, it would be termed a stationary front. Usually you have to deal with cold and warm fronts, and you can see this is how they form. You have your high pressure air from the continental polar, dry, cool, descending air, and the low pressure air from the maritime, tropical, warm, rising air clash in the mid-latitudes, and then you have cyclonic flow around the low where you get the warm front, warm air, cold front, high pressure system behind it. So this is the weather patterns for 2/3 of the United States. Right here is what you see. So your mid-latitude cyclone is the weather maker. Again, this image just shows you with map symbols how it works. Remember, the westerlies are moving this system, so it would move across the United States out to sea and fizzle out. Cyclonic flow, just a reminder, is counterclockwise around a low. They're station models. Remember, station models are how meteorologists transmit information. So they would get a map like this, and then they would draw in the lines, either ISO lines for temperature or barometric pressure, and then you would have your wind patterns. They would transmit that to the green screen during their weather broadcasts and talk to people, but they would use the station models and translate it into imagery for people to watch. So here's the cross-section of a mid-latitude cyclone. Warm front first, warm air, cold front after that, and then higher pressure behind it, moving toward the east from the west. This is what a mid-latitude cyclone looks like on the Doppler radar, where you have the cold front behind, and then clear air behind it. So look at Texas, a lot of clear air. You have the warm front in the lead, and then in between the two you have cloud cover. Notice the ball shape toward the top of the comma. That is the cyclonic flow or the low pressure. So you have low pressure in this region here. You have the warm front, and then the warm moist air, then the cold front, then the cool dry air. Thunderstorms are associated with rapidly rising air, and because cold fronts move the faster and push that warm air up, thunderstorms are most likely to be associated with a cold front pushing through. You can see that warm air rises, pushing the cumulus clouds up. Those cumulus clouds flatten off on top when they hit the top of the troposphere, and you have intense, fast-moving weather. Tornadoes occur with severe pressure gradients. Then you have to have large tracts of flat area. So, over the Gulf would be a water spout, tornado over the water. Flat, large, or over the Great Plains or the Plain States, you have a lot of flat area for that wind to really build up before it gets pushed up, and great speed occurs. So you can have small, weak tornadoes like the one on the left, or huge, massively destructive tornadoes like the one on the right, but they are associated with flat areas, extreme low pressure, and outstanding wind speeds. Now, hurricanes are a huge tropical cyclone that forms over the ocean, only in warm conditions, because you need that warm rising air full of moisture. Remember, they have a counterclockwise spin around low pressure. So you would start off as a low pressure depression, and as you moved across the ocean on the equatorial current, the trade winds moving you, you would increase your low pressure. The pressure would increase low pressure is kind of an oxymoron. Your pressure would decrease and decrease and decrease until you reach hurricane strength winds. When a hurricane moves over land or cool water, it dies because the rising air stops feeding the hurricane system.